Limit of a function. We already learned that we can evaluate limit of a function by direct substitution. Let's try to consider this example. Limit of x cubed minus 1 all over x minus 1 as x approaches 1. Substitute, we have 1 cubed minus 1 all over 1 minus 1 is equal to 0 over 0, which is indeterminate. Therefore, direct substitution is not applicable. How are we going to find the limit of the given function? There are functions that agree at all but one point. In other words, there is a function g of x that has the same limit as f of x, where we can apply direct substitution. So all we have to do is find that g of x. First method of finding out that g of x is using the dividing out technique, or basically factoring. Let's go back with the given limit of x cubed minus 1 all over x minus 1 as x approaches to 1. So we have the function. The numerator is the difference of two perfect cubes. So we can factor it as x minus 1 times x squared plus x plus 1 all over x minus 1. Since we have x minus 1 in the numerator and denominator, then we can cancel it out, given of course that our x is not equal to 1. Then we have x squared plus x plus 1, which is our g of x. Then we can try to find the limit of the g of x, so the limit of x squared plus x plus 1 as x approaches to 1 is equal to 3. Therefore, the limit of x cubed minus 1 all over x minus 1 as x approaches to 1 is equal to 3. If we try to look at the graph of f of x and g of x, then it will look like this. They are identical except on that one point, which is 1. Let's have another example. Limit of x squared plus 3x all over x as x approaches to 0. First, let's try direct substitution. Then it will give out indeterminate. So, what we need to do is factor the numerator, which is common monomial factoring, where x is common, so let out x, so we have x times x plus 3 all over x. Cancel x if x is not 0, then we have our g of x is equal to x plus 3. Finding the limit of our g of x as x approaches to 0, then we can apply direct substitution, then we have 3. Therefore, the limit of x squared plus 3x all over x as x approaches 0 is equal to 3. Another example, the limit of x minus 4 all over x squared minus 16 as x approaches to 4. If we apply direct substitution, then we get indeterminate. Let's simplify that function by factoring the denominator, which is the difference of two squares. So it will become x minus 4 all over x minus 4 times x plus 4. Cancel x minus 4, then our g of x would be 1 over x plus 4. Finding the limit of 1 over x plus 4 as x approaches to 4, direct substitute, then we have 1 over 8. Therefore, limit of x minus 4 all over x squared minus 16 as x approaches to 4 is equal to 1/8. Next example, we have the limit of x squared plus 2x minus 8 all over x squared minus x minus 2 as x approaches to 2. First, we have direct substitution, which gives out 0 over 0. So let's simplify the function. Factoring the numerator and denominator using factoring trinomial, we have x minus 2 times x plus 4 all over x plus 1 times x minus 2. Crash out common factor x minus 2. Then we get x plus 4 over x plus 1, which is our g of x. Finding the limit of our g of x as x approaches to 2. Then we have 6 over 3, which is equal to 2. Therefore, the limit of f of x as x approaches to 2 is equal to 2.